And if you want to find out the solution of this equation, you should know what is the complementary function and the particular integral. So we're going to look into how to find out the particular integral in the later part of today's class. For complementary function, we have to first write down the auxiliary equation. That means whatever is dx to the power n, 1, 2, 3, whatever, we're just going to take it to be capital D. So d would always be ddx. And also remember, if we take the reciprocal of d, we are actually talking about integration. Okay, we're talking about ddx here. So I can just replace it, put the values, equate it with 0, we get the symbolic form, and then we can actually write down the auxiliary equation. That means in place of d, I'm going to write down m. Once I have this, what I can do is I can use certain rules to find out the complementary function. So the first thing is, when we write down the auxiliary equation, equate it with 0, we can solve. Since the power is n, that means there will be n roots, and these roots might be distinct or might not be distinct. Okay, they might repeat. So let's say the first case is real, the roots are real and they are distinct, then this will be my complementary function. So this is something which you should remember, and this is a good example. We have got two roots, 1 and 2, and then this is our complementary function. Okay, we're going to look into different types. Sometimes the roots are real and equal, so the complementary function, whichever is the equal part, will have c1 and c2 together, and we have this example. I've discussed one, and then finally we have got the imaginary roots. Okay, so we are going to take up some more examples, and then we will continue with the next topic. So let's take some examples here. It will be a kind of three different examples that I'm going to take, so that things becomes a bit more clear. Okay, the first example is this, where I take, let's say, higher order, so it may be cubed 4, 5, 6, whatever, d cubed minus 2d square plus 4d minus 8 into y is equal to 0. Now you need to note here that its power is 3, that means there will be 3 roots to it, right? So we can actually write down the auxiliary equation, and that would be nothing but m cubed minus 2m square plus 4m minus 8 is equal to 0. And then what we can do is we can just, these are simple things which you already know, m minus 2 plus 4, and this is m minus 2 is equal to 0. So that means I'm going to get, m square plus 4, and then m minus 2 is equal to 0. I need 3 roots here, and I can clearly see that there are 3 roots. M is equal to 2 is a root from this, and this one would be m square is equal to minus 4. So if you just look into here, m square is equal to minus 4, that means m is equal to plus minus root over of 2i, right? So that means I can actually have 3 more roots here. So it will be plus root over of 2i and then minus root over of 2i. So I've got these 3 roots now. Okay, so once we have this, we can actually form the complementary function very easily. Cf is equal to, we have got one distinct root and 2 roots which are not distinct, right? So what you can do is you can take the first one, c1 e to the power 2x. You can take it the other way also, doesn't matter. You can take that c1 to be c3 and bring it later. And the other one would be nothing but, you see that there are imaginary roots here, right? So that means this plus minus root over of 2 pi can be written as 0 plus minus root over of 2 times I. So one real root, 2 imaginary roots. Okay, all are distinct.
2i.
Yeah.
Hello, sir.
Yeah.
In
The
place
plus
of
minus
root 2i,
2i.
it's 2i, na?
Yes, sir.
2i. Yeah. Oh, sorry. Yeah, it's 2i, not root 2i. Correct. Absolutely correct. Yeah, this is not root 2, right? Root is not there. So it will be this plus minus 2i, right? Okay, thank you for that. Just making a mistake here. Okay, so e to the power alpha x, and in this case, this is alpha and this is my beta. So that means I can just put e to the power 0x. I can keep it like this also, okay, if I write down the answer that way. And this would be nothing but, second variable is c2. First is c1, so next I can take c2. And the first term would be cos. If I take first term, sine also doesn't matter. cos 2x. Beta is this. So this is my beta, this is my alpha, and then I can write down this as c3 sine of 2x. Okay, so that's my answer. So usually you'll get these kind of problems and you have to solve it this way. Okay, so this is actually very easy. And okay, let me take one more example here. The more examples we do, it will be easy. We have to just remember those rules that we have. Okay, d to the power 4 plus 2d cubed minus 3d square into y is equal to 0. Okay, can anyone of m?
Yeah, yeah.
Okay, and not 2. 0 0.
Yeah,
Yes,
zero
there will
zero,
be
no?
two zeros will also be there. Okay, we have to actually include that. So basically what happens is when we actually write down the auxiliary equation m4 plus 2m cubed minus 3m square is equal to 0. I can just take this m cubed or m square common. So there basically it's m square. So that means I'm going to equate it with 0. That means there are two zeros that I'm going to get because of the power 2. And then we are going to have it here as m square plus 2m minus 3 is equal to 0, right? And then you can do your middle term factorization, and then you can get to be m plus 3 m minus 1 is equal to 0. So in that way you are going to get 4 roots, right? So you see the 2 roots are getting repeated and the other 2 roots are quite distinct. So can anyone tell me what will be the result for this? What will be the value of complementary function? You can also write it as y. Okay, two of the values gets repeated, so that's 0. So maybe I can write it down as c1 plus c2x e to the power mx. M is 0. 0 is the repeated value, so 0x plus the other two power values of m are distinct, so I can write it down as c3 e to the power x maybe plus c4 e to the power minus 3x. Now you have to note one thing, that if I put 0 0 at the beginning, I can take these two together. I put it later, I can also write down c1 e to the power x plus c2 e to the power minus 3x plus c3 plus c4x e to the power 0x. It's the same, okay? It doesn't make any difference, okay? That's there. So please, all of you, make sure that you solve it, understand it, okay? Otherwise it will be very difficult. There are so many problems. If you keep solving everything, you know the technique, and then whatever problem I might ask you, you'll be able to easily solve it. Okay, so that's I tell you, keep on telling you that solve all problems. Okay, let me give you one more example and tell me what is the final solution to this. Okay, don't tell me what is m, tell me what is the final solution. So now this is d minus 1 whole square, and then d square plus 1 whole square into y is equal to 0. 1 1. So you see there are a lot of repetition of the roots here. Okay, so if you just solve it, you will get m minus 1 whole square. So that means m is equal to 1 1 from here. You get twice, and then you get m square plus 1 whole square is equal to 0, right? So even if you don't do it, you already know it, right? Because you know m minus 1 whole square is equal to 0 implies m is equal to 1 1 1 1 because it's a square term, right? And then we have got m square plus 1 is equal to 0. It is a square here also, so that means uh, forget about square right now. You can just take this as m square is equal to 1 minus 1. So that means m is equal to plus minus I. And then let me explain it to you, or you try to understand it. It's very simple. c2x e to the power x. So I have done for this. I've done for this. These two one are gone. Now you see there are plus I, plus I, minus I, four values. 1 1. Okay. So that means there are six values. So depending on the six values, the constant should also be 6. So it will be C1, C2, C3, C4, C5, C6. Okay. Now in the second case, what happens is when we are talking about, let's say talk about this. This is 0 plus minus I. So that means beta is 1 and alpha is 0, right? So I can take e to the power alpha x, so e to the power 0x. Okay. And then within bracket, since the values are getting repeated, we know the rule for repetition is this. Rule for repetition is this. So that means I can put it as C3 plus C4x. Okay. And then this is a imaginary term. So I'll just put a cos x there. For imaginary term, it's cos. So I've taken care of, the I value also and the repetition also. What is getting repeated here? Let's say plus I is there. So that means your 0, 0 gets repeated here. Okay. Similarly, we can do the sine term also. So e to the power again 0x. We are actually having c5 plus c6x sine x. That should be your answer. Okay. Repetition rule remains there, and the integration rule also remains. Sorry, not the integration rule. I mean the you know sine and cos term for the imaginary term, whatever we are writing, that will be there. So think about it. Okay. This is the rule that we are going to use. So that's why I've used this problem specifically, so that we are clear that even if it is repeated for imaginary numbers, we can actually use the same rule of c1 plus c2x for that also. Okay, one will be cos, one will be sine. So in general, if we have a root as I, we simply write it down as e to the power x, okay, or maybe e to the power 0x, and within bracket cos x plus sine x, right, whatever is the coefficient. So this one, right? C2 cos x and C3 sin x. It may be 1, so I will just put 1. This 2 here, so I'll put 2 here. Okay. Same rule. So please, when you do it in your exam, also take care of that. The first thing that you should see is how many roots are there. 6 roots. There should be 6 constants. C1, C2, C3, C4, C5, C6. Right. That's it. Okay. Next, we are going to talk about particular integral. So in CF also you are going to get different kinds of problems. So if you know the rules, you can tackle all of them. So let's talk about PI, particular integral here. Okay, and particular integral is also simple. We just need to know certain rules so that we are able to solve problems of particular integral. Okay, so let's see, we have got this FD. FD means symbolic form. Okay, just in terms of D, Y is equal to, let's say, Q. Why we need particular integral? Because everywhere we are saying it is a 0 in this side. It might not be 0. Who said it should be 0? It can be anything else also. If it is something else other than 0, we also have to find out the particular integral. For complementary function, we will actually just equate it with 0 and solve it in this way. And then for particular integral, we have to consider that value whichever is there on that side, okay, and then solve it. So that's why particular integral is important to do. If it's a 0, you don't have any particular integral. But if it is non-zero, there is a particular integral also to that equation. So y will be equal to q divided by f of d. So this is the form of particular integral that we are going to get. But then, if the values of q are different, you are going to get different forms and different ways of solving it. So let's say, take the first example. Let's say if q is equal to e to the power ax. I'm just going to give you the general rule. E to the power ax. That means y is equal to q will be there on top. Okay, so in q we know it is e to the power ax, so I can just replace it, e to the power ax divided by f of d. Okay, and if that is the case, we can simply write it down as e to the power ax, and whatever is d, I'm going to write it down as just a. I'm going to replace that d, that means d dx, with a, whatever is the value, provided that fa is not equal to 0. Once I replace it with a, it should not yield fa is equal to 0. If it yields 0, that means I cannot do it this way. If f of a is equal to 0, then I have to go one more step. I have to, on top, I have to write it down as x e to the power ax divided by f dash of a. I'm going to give you an example so that it's clear. F dash of a should not be equal to 0. So I'm going to keep on differentiating this unless I get a non-zero f dash a, f double dash a, f a, whatever. Once I get f a is not equal to 0, it's fine. I can straight away find out the particular integral. I don't get it to be, if I get it to be 0, I'll differentiate it and see f dash a is not equal to 0. And I'm going to keep on doing that until and unless I get the answer, okay, which is non-zero. And then I'm going to get the particular integral. But I'm just giving the rules, it will be not clear. So let me just take one example and then let's discuss that problem. Then it should be more clear to you. So I will take one example here. Maybe let's say take this t square minus 3d plus 2 is into y is equal to e to the power. So this side is not 0, e to the power 4x. Now you want to find out the solution for this problem. That means you have to find out the complementary function as well as the particular integral. So let's complete it. M square minus 3m plus 2 is equal to 0. I think we have already done it. So if you solve it, you'll get the value of m as 1 and 2. So that means my complementary function y, I can write it down here. It will be nothing but the values are not getting repeated. So c1 e to the power 1x plus c2 e to the power mx. So it will be 2x. Right. So I've got the complementary function. I want to find out the particular integral. We can just write down y is equal to e to the power 4x, that's my q value. Okay, if you look, we compare it, divided by ft, whatever is the function, d square minus 3d plus 2. Okay, so this is important. Okay, and in place of d, what I'm going to do is I'm going to put whatever is the coefficient of uh, e to the power ax, whatever is the value of a. So this is my a. Okay, this is my a, don't get confused here. So I can just simply write it down as e to the power 4x divided by a square or 4 square, let me write it down directly, 4 square minus 3 into 4 plus 2. So I have to check whether this is 0 or non-zero. Okay, if this is 0, then I don't take this step, I differentiate and then I take the step. Okay, but anyway I know it is non-zero because 4 square is 16, 16 plus 2 is 18, and 3 into 4 is 12, so it is 6. So it will be e to the power 4x divided by 6. So now the complete solution of this particular problem would be y is equal to complementary function plus particular integral, which is equal to c1 e to the power x plus c2 e to the power 2x plus e to the power 4x divided by 6. Okay, so this is the solution for this problem. So whenever you are getting a problem, you have to find out the total solution. I have done it by parts. First I've told you how to find out the
Sir,
different
hello,
ways
sir.
of yeah.
Hello, sir. Sir, can you please explain from particular or integral in this question?
Okay, so when we actually solve it, this is exactly what I was explaining actually. I'll start. When we are actually solving, you cannot just find out complementary function and then leave it there. You have to do the particular integral also. You only do particular integral if on this side there is some value. If this side is 0, there is no particular integral as such because this will be 0. Okay, but then if you want to, it's non-zero, you have to find out the particular integral. Now finding the particular integral actually depends on what is there on this side. Is it e to the power ax? Okay, might be something like a function of sin x or cos x, whatever. Okay, so it depends on what is here, and depending on that you are going to use the rule. So in particular integral, what you do is pi, you find out y, which is the solution, particular integral solution is equal to whatever is on this side. So in this case it is e to the power 4x, so I'll take e to the power 4x on top divided by this symbolic form of the differential. This is the symbolic form, if you remember I told you. Okay, I'll just repeat this if someone has missed out the last class, I don't know. So this is actually the symbolic form which I told. You have dny dxn, you can write down d to the power n, where d to the power n is nothing but d dx. This is actually the symbolic form. So if I'm writing down f within bracket d, that means I'm talking about the symbolic form. So I'll divide it by the symbolic form is equal to e to the power 4x, and in place of this capital D, in place of this capital D, I will put a. So I'll put a is equal to 4. Here also I'll put a is equal to 4. What is my a? Whatever is the coefficient of x. So I'll put that here and see that this is non-zero. This is non-zero, this becomes 6. So this is the solution of particular integral. Let me take one more example where actually it becomes 0. Okay, Let's solve few problems. The more we solve, the more clear it becomes. Okay, let's take an example here. Okay, I'll do it. I prefer doing this also. D cubed minus 2d square plus 4d minus 8 into y is equal to e to the power, let's say 2x. It's plus 2x. Okay, so if you know find out m values, I'm not going to solve it, you already can do it. It will be 0. There's 3, so there will be 3 values of m. It will be 0 and plus minus 2i. I think we have already seen it once. So just to just for the completeness of the answer, I'll write down the complementary function. This is c1 e to the power 2x, right, plus e to the power 0x. Okay, this is there. So 2i plus minus 2i. So this is c2 cos 2x. If you're confused with complementary function, please check the previous notes. Okay, sine of 2x. So this is done. Okay, so once this is done, okay, this is, sorry, this is not 2, this will be 0, right, because this is 0. Okay, so once done, okay, we can actually find out what is my particular integral. Now particular integral would be nothing but y is equal to e to the power 2x divided by d cubed minus 2d square plus 4d minus 8, okay, divided by the symbolic form. But you know, there is a problem here. When d is equal to 2, we get this relation to be 2 cubed, which is 8 by 2, because this is 2, this is my a. So this is 8 minus 2 square is 4, 4 into 2 8, plus 4 into 2 again 8, minus 8. So you see there are 2 plus 8 minus 8, so it will become 0. So that means this cannot be the solution for the particular integral, right? So that's why I cannot write this as the solution. So this you have to do it beforehand, okay, and check that it should not be 0. If that's the case, okay, if it becomes 0, what we do is we take the next form. The next form is we'll put an x in front of e. This will be x e to the power 2x divided by the differential of this. Okay, so if we just differentiate it once, okay, d cubed, it will become 3d square minus d square will become 2d, so it will become 4d. 4d, this is plus 4d, so it will be just plus 4, minus 8 will be 0. Let's just try this again. Now d is equal to 2. What happens to this? This is 3 into d square, so that means 3 into 4, so that is 12, minus 4 into 2 is 8, plus 4. So that means this is becoming 12 plus 4, 16, minus 8 is 8. So it is becoming 8. So that means this is valid, right? So that means what we can do is, this will be the particular integral. The particular integral would be x e to the power 2x divided by, well, let me write it down directly as 8. You know why it is 8, right? Because of this. So this is 8. So that means the value of y would be complementary function plus particular integral. So don't get confused here. It's actually important, and when you keep doing it, you will see that it's quite obvious. The denominator cannot be 0 for having a solution of a function. You cannot have a solution of y with the denominator to be 0. When you put the value of a, you get it to be 0. That means obviously that's not the solution. What is the next step? You take the ddt of, or you can say, I can just, maybe I will write it down here, dd of capital D of whatever is the function, right? Do that, put it at the denominator, and on the top you will have an x multiplied, and then you will get the answer if the denominator is non-zero. Again, if the denominator is 0, suppose if you put 2 again, it becomes 0, you can again differentiate it. If you differentiate it here, here also you have to differentiate it, so you'll get, in place of x, you're going to get x square. Here also it's actually differentiation, okay, but this differentiation is with respect to the constant. So instead of remembering that this differentiation is with respect to the constant, keep on adding x there. X, then if the next step it will be x squared, then x cubed and so on, until and unless the denominator becomes non-zero. Okay, so please take care of these kind of sums. These sums are actually important. Should not get confused here. Okay, this is important. Okay, I will give you one more form of particular integral. One form we have already checked. That means it is e to the power ax. In the next form, I say that we have got f of d square and d. It may be a function of d square and d. Okay, into y. But the trick here is d square and d, if you replace d, you cannot replace with d square. Okay, I'll show you an example here. F of d square or and d function into y is equal to, this side it is sine ax or maybe cos ax. So what I want to say here is that on the right hand side it's sine now or cos. It's a trigonometric function. It's not e to the power ax. If it was e to the power ax, you straight away replace the value of a in this d square. But here it
Hello,
is sine ax or cos ax, you cannot replace it. That's not the rule. Yeah, Sujita, tell me.
sir. Actually, na I was left out automatically and couldn't join earlier. That's why
Okay.
last slide. Can you show me again?
Yeah, yeah, yeah. Which part you missed? This one, have you seen this problem I've given?
Yes, sir. I have done it. And the
Yeah, yeah.
last answer. Yes, sir. Yes, sir. Okay, sir. Okay, sir. I
Is it
got
okay?
the same.
Okay. So whatever rule you are going to use to solve the complementary function will actually depend on what is there on the right hand side. So in the first case we saw that on the right hand side it is e to the power ax, and we solved it in this way. We replace the a value in d, check whether it is 0. If it is non-zero, we solve it. If it is 0, we differentiate and then we solve it. But if it is sine, the rule is slightly different. We have to write it down in this way. Y would be again nothing but sine of ax. I'll just take the example of sine divided by f of d square and or d, okay, function of this. And here what we do is we write this as sine of ax divided by f of, in place of d square, please remember this, in place of d square we are just going to put a minus a square. Minus a square, minus is also important. And d, we are not going to do anything with d, we are going to leave d as it is. This happens only when we are considering a sine or a cos function. So if it is a cos function, it will be nothing but cos of ax, same thing. And if you're given a problem specifically, you'll be given a sine or cos function. Okay, so don't worry, you're not going to be given any other kind of variation. Even in entrance exam also, no other variation will be given. They just want to test whether you know the rule or not for finding out the particular integral. Okay, that's it. But then, as I said, just looking into the rule is difficult to understand the problem. Let's take a numerical here. So d square minus 2d plus 3 into y is equal to cos of 2x, right? We will find out the auxiliary equation here, and then this will be m square minus 2m plus 3 is equal to 0. Okay, so this will imply that m is equal to 3 and minus 1. So complementary function would be nothing but c1 e to the power 3. Maybe I just missed out that minus. So then I think this is fine now. Okay. Okay, anyway, this is okay. So we have got it as cos of 2x. Okay, the rule is cos of 2x, and then divided by d square minus 2d minus 3. Okay, we have it here. And now what happens is, in place of d square, we are going to replace it with minus a square. What is my a? My a is 2, cos of ax, so a is 2. So that means I'm going to write it down as cos of 2x divided by, this should be minus 2 square. In place of d, I'm going to write down a, that is 2, and I'm going to put a minus sign there. Don't miss out that minus sign. Minus of 2d. So most of the time students make this mistake. In place of d also they are going to take 2, but that's not true when you actually are doing a function of sine x or cos x. Okay, so that means this will be minus of 2d, and then this will be minus of 3. So if I take it, I will get it to be cos of 2x divided by, this is minus 2 whole square, so that is minus 4 minus 3. So I can take the minus sign here common, and then I can write it down as 2d minus 7, right? 4 3 7, yeah, it's correct. Now what I can do is this. Okay, this is a trick that again you should remember. First thing is I can rationalize it. So rationalizing means I can just multiply it with 2d plus 7, and here also 2d plus 7, and I hope you understand why I'm doing this, because we're going to get a d square term again. So this is 2d plus 7 cos of 2x divided by, this is a plus b into a minus b, that means it is 4d square, okay, minus 7 square. So that means I can write it down as 4d square. In place of d, again I can take minus of a, so this will be minus of 2 square, 4d square minus 7 square is 49. So in that way what we can do is we can actually get a minus sign here, and this would be 2d plus 7 cos x divided by 2 square is 4. Okay, so that's 4 into 4 16, so minus 16 minus 49, so it is minus of 65. Get rid of this minus sign now. Okay, and do it on the same page, otherwise we'll miss out. If I continue here, I can just write down y is equal to, this is 2 times d. What is d? D is d dx, right? D is d dx. So that means d dx of cos x. So this is 2 times.
Hello, sir. Hello,
Yeah,
sir.
yeah.
Sir, in that pi term,
Mm-hmm.
cos 2x uh, by, sir, that is 2d plus 7. If we take minus sign out,
Which one? Oh, sorry. Yeah, this is 2d plus 7, right?
just take that is minus 2 का whole square और minus बाहर है 2 square में.
Minus 2 square से बाहर है, so it will be minus 7 minus 2d. So this is, yeah, this is correct. 2d minus
Yes, sir,
7.
2d
Sorry.
plus 7 आ रहा है.
Sorry, I did my mistake. 2d minus 7. So I'll rationalize it with 2d minus 7. So
Yes,
this
sir.
will be 2d minus 7, right? So this is 2d minus 7. Bottom will remain the same. 2d minus 7. Correct. Thank you for the correction. So keep on happening. Okay. So this is 2d cos x minus cos x. And what is d? D is d dx. So d dx of cos x is actually nothing but 2 minus sin x. So I can just write it as minus 2 sine of x minus cos of x
Sir,
divided by,
sir,
yeah,
sir, cos 2x.
uh-huh.
So this was cos 2x, 2d cos 2x minus.
Sorry, this is cos 2x. Oh yeah, यहाँ पे मिस हो गया मेरा, cos 2x. So if this is cos 2x, this is also cos 2x. Okay, please do it clearly. I've just made a mess here. So this would be a 4, right? This would be 4. So this will be your particular integral, minus 4 sin x minus cos x divided by 65. Okay, that means if you want to find out the entire solution, you can always write it
Sir, I
down as complementary
got
function
minus
first.
4. Hello,
Yeah,
sir.
yeah.
Sir, I got Hello, sir. I got the particular integral as 4 sine 2x minus 4 sine 2x minus 7 cos 2x by 65.
Minus,
4 sine 2x
right.
minus 7 cos 2x.
Second cos 2x, I didn't get it. Can you just, oh, 7, yeah, 7, right. Oh yeah, I did not multiply 7, correct. Yeah, it's correct only. Just normal algebra, okay. I've mixed up so many things here, that's why it just got mixed up, okay. But anyway, I think you can do it. It's correct only, yeah. Divided by 65. So y is equal to complementary function plus particular integral, and you do it, okay? And most of the times you will see that the terms which are there in complementary integral and the particular integral, it will be very difficult to combine. So just leave it as it is, okay? And that is the rule that we are actually going to use here, okay? Let me give you a sum for you to do, okay? So I will do it on a clean slate, okay? I think this time we can do it better. D square minus 3d plus 2 into y is equal to sine 3x.
Hello, sir.
Yeah.
I got the answer. Complementary function as a whole, I will tell, or
Tell me the complementary function first. This is something which I am writing on the screen also. So
okay,
maybe
sir.
this is the answer, right? c1 e to the power x plus c2 e to the power x. ठीक है ना ये?
Okay, yes, sir. But I have taken the 2x first and then
Yeah,
x.
yeah. Doesn't really matter. Okay, we can do it any way we like. Tell me the particular integral that you're getting. Complementary function. I think all of us are an expert right now.
Sir, the particular integral is 9 cos 3x
9 cos 3x
minus 7 sin 3x
minus 7 sine 3x
by 130. 130.
130. Okay, what about others? I think I don't know actually. I really did not do a calculation for this, so I also don't know. What about others? How much they're getting?
Hello, sir.
Yeah,
Same answer.
same answer. Okay, so that means that should be the answer. Others also, please try and tell me how much you're getting.
Yes, sir, I am getting the same.
Okay, so that means that's the answer. Okay, but anyway, मैं थोड़ा कर लूँ practice. 9 minus 9 plus 2 7 minus 7 minus 7 minus of 3d. So we have this. Okay, so we can just simplify. यहीं पे कर लेते हैं, यहाँ माइनस ले लेते हैं, प्लस हो जाएगा, ये प्लस हो जाएगा. So I can take this to be 7 minus 3d. This is 7 minus 3d. So this would be minus 7 minus 3d to sine of 3x divided by a square, that is 7 square minus 3 into minus of 3 square. So this should be minus 7 sine 3x minus minus हो गया plus, this is 3, and then there will be ddx of sine 3x, so it will be 9. 3 into 3 9. फिर ये हो जाएगा cos of 3x divided by, ये हो गया 49, and this is 3 square is 9. 9 into 3 is 27 plus 27. 49 plus 20. Denominator, why I'm getting this? Am I doing something wrong here? 7 square, oh sorry, this is 9. 3d square है ना, 9 होगा ये. So this is 9 into 9, 81. So 49 plus 81 माने 130. Okay, 130. Okay, so I'm also getting this, so it should be correct, I guess. Same here, same here. Okay. Okay, so this should be the answer. So this is your particular integral. So in exam, when you write down the solution, you just write it down, y is equal to cf plus particular integral. Okay? So if you do it, that's okay. For these exams, NSEM exams and all, don't concentrate on speed, rather concentrate on accuracy. Very important. Okay, detailed accuracy is very important. Only